Differential calculus part 8, in which we are going to see the application of differentiation in marginal cost and marginal revenue. Myself, Professor Vaishali Bharat Gholab. First of all, we need to understand the basic concept of the cost. That is, first is total fixed cost. Total fixed cost is the cost on which the output level does not have a direct impact. Okay. Average fixed cost is a total fixed cost upon total quantity produced. Total variable cost is a cost on which the output level have a direct impact. As in case of fixed cost, we establish our all fixed requirement, that is plant, machinery, equipment. Okay, that's why we can say that the cost on which the output level does not have a direct impact is called as total fixed cost, and the variable cost is a cost required for producing the output, that is raw material, uh, labor, expenses, all are the part of your variable cost. Okay, that's why the variable cost is the cost on which the output level have a direct impact. Average variable cost is nothing but total variable cost upon quantity produced. Total cost is nothing but sum of the total fixed cost and total variable cost at different output level. Total cost is equal to total fixed cost plus total variable cost. Average cost is the total cost upon total quantity produced. Marginal cost. Okay, we are using differentiation for finding the marginal cost. What is meant by marginal cost? Marginal cost is nothing but increase or decrease in the total cost by producing one additional unit, or we can say the additional cost incurred to produce one more unit of the output. This is the basic concept of cost. Now we are going to see the revenue. Okay. What is meant by revenue? The total revenue is refers to the income of a firm or producer from the sale of total goods and services. Then what is average revenue? Average revenue is the revenue per unit of output sold in the market. That is also called as price per unit of the commodity. Marginal revenue we are going to use. In this video we are going to see the application of differentiation for marginal revenue. Marginal revenue is nothing but the rate of change of total revenue with respect to the number of items sold at an instance, or we can say the additional revenue that a firm or producer obtain by selling every additional unit of the commodity in the market. This is the basic concept of cost and revenue. Now, see, this is also the graphical representation. First of all, we need to understand y-axis, x-axis. Y-axis represent cost and revenue. X-axis represent the output. Okay. You can see here fixed cost. Fixed cost is nothing but the cost incurred on plant, machinery, equipment, which is fixed, which is need to be incurred before starting our production. Okay, that is a fixed cost. Then variable cost is you can see the graph of cost function. Okay, here fixed cost is completed, then variable cost graph is, that is cost function. Cost is a function of output. Output is represented by X. Okay. As we increase our output, the variable cost is increased. You can see. That's why the definition we have seen, that is revenue or total fixed cost is a cost on which the output level does not have a direct impact, and variable cost is the cost on which the output level have a direct impact. Okay, which we can see in this graph. Then you can see the green line, that represent the revenue function. Revenue function is also function of output. Okay, as your output increase, revenue is increase. The revenue function start from the zero or origin. This is the total cost function, which include fixed cost and variable cost, and revenue graph is green color. You can see that is revenue function. R is a function of X. Now marginal revenue and marginal cost. You all know that what is meant by derivative? Derivative is nothing but the rate of change. And what is marginal revenue and marginal cost? That is also rate of change. Okay, that's why marginal revenue is the differentiation of revenue with respect to X, that is output, and marginal cost is also the differentiation of cost with respect to X, that is output. This is a graphical representation of cost function revenue function, marginal revenue and marginal cost. Now we are going to see the problems. See, first problem, if a manufacturer total cost function is C is equal to 0.1x square plus 3, find the average cost function and marginal cost function and marginal cost when 4 units are produced. Okay, what is asked? We need to find out the average cost, and marginal cost when 4 units are produced. First of all, what is the average cost? Average cost is the total cost upon quantity produced. Total cost is given, that is 0.1x square plus 3 and quantity produces x. Then we will get the average cost as 0.x plus 3 by x. This is our average cost. Now we want to find out the marginal cost. Marginal cost is nothing but the derivative of cost function with respect to x, or we can say output. Total cost function is given, that is derivative of 0.1x square plus 3 with respect to x. You know that 0.1 is a constant, that's we bring outside 0.1 into derivative of x square is 2x. That's why 0.2x is the derivative of 0.1 x square plus 3 is a constant, that's why derivative of 3 is 0. Means what is the marginal cost? Marginal cost is 0.2 x. Now what is asked next? The marginal cost when 4 units are produced. Okay, marginal cost as 4 unit. We simply put x is equal to 4. We will get marginal cost at 4 unit. 0.2 into 4, that is rupees 0.8. That is the marginal cost at unit at 4 unit. Next problem, the cost of producing x tons of units is given by, cost is a function of x is equal to 1 upon 10x square plus 5x plus 1000. Find marginal cost function and marginal cost when x is equal to 1000 ton units are produced. Okay, what is marginal cost? Marginal cost is nothing but the derivative of cost function with respect to output, or we can say x. Okay, derivative of cost function. Cost function is given 1 upon 10 x square plus 5x plus 1000. Then derivative of 1 upon 10 x square is 2 upon 10x plus derivative of 5x is 5 and derivative of 1000 is 0. Means marginal cost is 1 upon 5x plus 5. Now we need to find out marginal cost when x is equal to 1000. Simply we put in marginal cost function x is equal to 1000. We will get marginal cost at 1000 unit. 1 upon 5x plus 5 is equal to 1 upon 5 into 1000 plus 5. 5 divided by 1000, that is 200. 200 plus 5, that is rupees 205 is the marginal cost at 1000 unit. Next problem, the total cost C associated with production of x unit of an item is given by C of x is equal to 0.005 x cube minus 0.02 x square plus 30x plus 5000. Find the marginal cost when 3 units are produced. Since marginal cost is the rate of change of total cost with respect to output, means marginal cost is nothing but the derivative of cost function with respect to x, or we can say output. The cost function is given, that is 0.005 x cube minus 0.02 x square plus 30x plus 5000. Derivative of this function is 0.005. Derivative of x cube is 3x square minus 0.0. Derivative of x square is 2x plus 30. Derivative of x is 1 plus 0, that is derivative of 5000 is 0. Means marginal cost is 0.015 x square minus 0.04x plus 30. This is the marginal cost function. Now we need to find out marginal cost when 3 units are produced. We simply put x is equal to 3 in a marginal cost function. We will get marginal cost at 3 unit, that is rupees 30.015. Now the total cost associated with production of x unit of an item is given by C of x is equal to 0.007 x cube minus 0.003 x square plus 15x plus 4000. Find marginal cost when 17 units are produced. Since the marginal cost is rate of change of total cost, That's why we find out the derivative of cost function with respect to x, or we can say the output. We will get the marginal cost. Cost function is given that 0.007x square minus 0.003x square plus 15x plus 4000. Now 0.007 is constant. Derivative of x cube is 3x square minus 0.003. Derivative of x square is 2x plus derivative of 15x is 15, as derivative of x is 1. Derivative of 4000 is 0. That's why marginal cost function is 0.021 x square minus 0.006x plus 15. Now we need to find out the marginal cost when 17 units are produced. We simply put x is equal to 17 in a marginal cost function. We will get marginal cost at 17 units, that is rupees 20.967. Now revenue function example. The total revenue received from the sale of x units of a product is given by, as revenue is a function of output, R of x is equal to 3x square plus 36x plus 5. Find marginal revenue when x is equal to 5. Since marginal revenue is a rate of change of total revenue with respect to the number of units sold, we find out the derivative of revenue function with respect to output, or we can say x. The revenue function is 3x square plus 36x plus 5. Derivative of 3x square is 3 into 2x plus 36. Derivative of x is 1. Marginal revenue is 6x plus 36. Now marginal revenue at 5 unit, we simply put x is equal to 5 because we want to find out marginal revenue at 5 units. We simply put x is equal to 5 in revenue, marginal revenue function. We will get marginal revenue at 5 units, that is rupees 66. Next problem. The total revenue received from sale of x unit of a product is given by R of x is equal to 13x square plus 26x plus 15. Find marginal revenue when x is equal to 7. Since the marginal revenue is a rate of change of total revenue with respect to number of output or number of units sold, simply we find out the derivative of revenue function with respect to x, or we can say output. The revenue function is 13x square plus 26x plus 15. Derivative of 13x square is 13 into 2x plus 26. Derivative of x is 1. Derivative of 15 is 0. Marginal revenue function is 26x plus 26. Now we want to find out marginal revenue when x is 7. Okay, simply we put x is equal to 7 in marginal revenue function. We will get marginal revenue at 7 units, that is rupees 208 or 208. Thank you.